Hi everybody. Let's take a moment here, just kind of pause from what we're doing and just take a quick look at what happens when you've got 0 as an exponent. I think most of the time you get taught this and people know what it is, they know what the answer is supposed to be, and yet frequently when we get to like high school, this is one of those things that we as teachers know that we can catch you on. I can use a very common misunderstanding about this on a multiple choice question, and I'll catch people on it, okay? But it's a simple concept. It's a very simple concept, but I think sometimes people just respond to it by rote without actually knowing why the rule is the way it is. So let me show you what's going on here. And we'll come up to this in a second here. I'll explain what this is, but x to the 0 is equal to what? Well, let me establish a pattern here first. Let's just grab a number here. Let's say I grab 2. Let's say 2 cubed. I know that 2 cubed is going to be 8. Okay? That's 2 times 2 times 2. Now, one of the more common mistakes made here is people just immediately multiply those together. And that's usually when they're not really thinking carefully about this because they're maybe thinking about a different part of the problem. So please watch that. 2 cubed is equal to 8 here. Now, 2 squared is equal to 4. And 2 to the 1 is equal to 2. Now, what I'm doing here in every case here, notice that what I'm doing is I'm subtracting 1 from the exponent. As I go down, subtract 1 from the exponent. Okay? Here, on this side, I'm dividing by 2. I'm dividing by 2. Now I could have started higher. I could have started at like 2 to the 5th and worked my way down here, but I don't really need to. I think the pattern is fairly clear. So now what I'm going to do is I want to extend this one step further. What I'm going to do is I'm simply going to subtract 1 from the exponent. And when I do that, I'm going to divide by 2. So when you subtract 1 from the exponent, that's going to leave you with 2 to the 0. When you divide by 2 on this side, that's going to leave you with 1. So 2 to the 0 is equal to 1. It has to be like that so that this particular pattern holds. Sometimes there's this idea that math teachers, mathematicians are arbitrarily putting a rule here that doesn't make sense. But actually in this particular case, no, it makes a lot of sense. Here, let me show you. Let's use a different base here. Let's say it's 5. Let's say it's 5 cubed. Well, I know that 5 cubed is 125. I'm going to subtract 1 from the exponent to get 5 squared. I'm going to divide by 5. And when you divide 125 by 5, you're going to get 25. And that makes sense. 5 squared is 25. Okay, so that's consistent. I'm going to subtract 1 from the exponent to get 5 to the 1. I'm going to divide by 5 to get 5. And that makes sense. 5 to the 1 is equal to 5, so I'm being consistent. Go one step further, subtract 1 from the exponent, I get 5 to the 0, divide 5 by 5, and I'm going to get 1. It doesn't matter. It doesn't really matter what the base is. The base could be anything, okay? The issue really boils down to the transition from this step to this step right here. So if you've got, for example here, if we got this as y to the 1, I know that's going to equal y. If you subtract 1 from the exponent, you're going to get y to the 0. If you divide that side by y, you're going to get 1. Doesn't matter. Doesn't really matter what the base is, to a point. To a point. Now I'll explain that in just a second before we sign off here. So what I know here is that x to the 0 is going to equal 1. Except there's one little thing I got to state there, just before we finish this off. X to the 0 is always going to equal 1 so long as, x does not equal 0. 0 is an odd duck here, and I don't mean odd in the sense of even odd. I mean it's a strange thing. Okay, 0 behaves a little bit wonky here. 0 to the 0 is actually, you're going to find later on in one of those further on math courses, is what we call an indeterminate form. Not quite sure what that means, and I'm referring more to a calculus context. That's where you're really going to see that pop up. There's probably, other people are going to say it's undefined and whatnot, and that's probably true. Most of the time when I approach it, we approach it as an indeterminate form because of what we're doing. But regardless, just know that when the base is 0, 0 to the 0 is, I don't know. But anything else to the 0 is going to give you a 1. And this is why, just to follow that pattern.